D. Ventricular septum ventricular septal defect. Okay, this is an evolutionary trait that humans have. It's a defect. It's rare, but it happens in people, and they have to be corrected. This is coinciding with the three-chambered heart. Okay, there's a gene in us, because we are related to reptiles and all of these other animals, that still wants to form a three-chambered heart, even in a human. Because it's a genetic defect. Because genes, man. It's all about genes. Alright? So this is what's going on. They have to literally, they have to correct it. Okay? They have to correct this, or it'll kill a person. It's a heart disease. So, literally, our evolution still kind of remembers its past. And every great once in a while, it'll apply that to a modern being, and it'll be an evolutionary fluke, or it'll be a heart disease, or it'll be some kind of disease, congenital disease, you know. So we can see now, well, I can see it, why we have certain diseases that we have, by understanding our evolution better. So they understand kind of the evolution of the heart, but they don't see how everything coincides. If they understood that, they would understand what genes need to be activated or deactivated to create or prevent a problem that would result in a congenital defect. You know, by changing or adding or removing something that's going to cause a problem in the future. Okay, so this TBX5 gene, okay, TBX5 is involved with the development of four-chambered hearts in the four chambers in the heart, the electrical conducting system, and the septum separating the right and left sides of the heart. So somewhere in this area here, again, the TBX5 gene is going to be born. This gene is going to be activated or come out of nowhere. I don't know. Okay, I don't know much about genes. I know a little bit. I know that it's a chemical reaction. It's biochemical synthesis. Regardless of how it came to be, if it was there already and then was enabled, or if it got in, or if it literally was formed during this phase right here, the stage. I just know that somewhere in here, this TBX5 gene started to become active. And once it did, the ducks, the birds, all of these animals started evolving four-chambered hearts. And all of these crocodiles started evolving four-chambered hearts. So somewhere in here, this TBX5 gene was activated. Okay, also, your forelimbs, alright? It's a forelimb, it involves the forelimbs and the heart, okay? This would literally be where the wings are starting to evolve also, okay? So, you still have what genes that create its legs, but this TBX5 is going to start changing the heart and the arms, essentially creating a four-chambered heart and wings. You see what I'm saying? See, the encoded protein may play a role in heart development and specification of limb identity. Holt-Oram syndrome. This is a defect of the heart and your forelimbs because of this gene. So again, this is an evolutionary trait that we will inherit from this side of the family that's deep in our DNA somewhere. And by understanding this latter, we can understand our own genome better. And we can work on preventing diseases and birth defects and such.